So hello everyone, today I want to talk about the LEDs, specifically blue LEDs. To start, I want to show a picture and mention that. Do you remember the last photo you have taken with your mobile phone or your camera or your computer? Can you imagine it without colors, specifically blue one? Let's imagine what do you think about how it could be without blue color? Is that okay or not? Let's see. Let's see. Is that okay? I think not. So today I want to inform you about how the progress of development of blue LED and why it is one of the most important modern technologies in our modern life. So let's start with colors. There are three main colors that we can say it is red, blue, and green. And by using proportion, we can get approximately 60 million different colors. To compare that, we can say that if a human start to try a new color in a second for his or her life, he even can finish it. So, as you see, there is three main colors, and let's say we want to try to mix them. If we mix red and green, we will get yellow. If we mix the red and blue, we will get pink, and so on. So the biggest problem starts with there. How we decided to which proportion should we choose. In this action, we will learn about pixels. Pixels is a frame that contains three LEDs inside, and it automatically decides which proportion it needs to take. Okay, but what is LEDs and how it actually works? LEDs stands for light emission diode, which is also, we can mention that it uses battery or some DC electric energy to produce light. But how it works? As you see, this image describes so complicated information. So let's use a simple example to understand this phenomenon. I want to give a waterfall experiment. They both have the same working principles, so we can say that instead of electrons, we can take water. As you see, water starts top of the river and ends at the bottom of the water flow. So as you see here, electrons going through cathode to anode, which means they are moving to high level to low level. As you see, these are the same progression, but however, we can say that this is only about the transmitting. What about lighting? So we need the source component. Our source component is water electric generator. And we need in here, as you see, the gray semiconductor. They have both same working principles. Water moving one point to another, while water moving one point to another, this generator starts to provide this electricity. The same purpose works with this. While electrons moving through the semiconductor, it starts to give some different kind of colors. So the type of color of light depends on the material of the semiconductor. So the main part is that if we can choose the correct material for semiconductor, we can get the true kind of color. So as we mentioned that, we need specifically three colors: red, green, and blue. As you see, I mentioned that red and green are easiest one. the most challenging one is the blue. You may assume that white is more hard to develop from the red and the yellow. Because if you choose any kind of semiconductor, if you give some electricity to them, it will start to melt up, or some low-level energy light. This can be end up with disadvantage. So at the end of the 20th century, the three greatest research figure out the gallium nitride is the best semiconductor for blue LEDs. So they in the 2014 they got the Nobel Prize in physics field for this invention. And lastly, we can say that after this invention, they removed the limitation on developing the RGB lights. So now today we are able to use this technology. To conclusion, one of the most important technologies in modern life is blue LED. So that's why we are calling it source element to shine. Thank you for attention.